Hello, my name is Matthew Hitt, and I'm with the U.S. Army Space and Missile Defense Command, and I'm going to be presenting on the last decade of effort in the Army SMDC's involvement in space. So to start off with, the U.S. Army had a prominent role in the nation's early space endeavors. In particular, one of the main achievements was launching America's first satellite, Explorer I, in 1958. However, in the 1960s, the Army relinquished its role in space to the U.S. Air Force and to NASA, and so the Army went from being a provider in space to being a voracious user of space-based data. In 1997, then, the Army established a major command, the U.S. Army Space and Missile Defense Command, SMDC, to serve as the Army proponent for space and national missile defense, as well as the overall integrator for theater missile defense. In the mid-2000s, Army's return to space began when SMDC developed a paradigm that very small satellites could have tactically relevant uses and started putting effort in that area. So the first example of this was SMDC-1, the Space and Missile Defense Command Operational Nano-Satellite Effect, which was first launched in 2010. It was the first Army satellite in 50 years. It was a 3U volume CubeSat, and as you can see in the picture at the bottom, 8 of them were produced. 6 of these were launched into space, and 2 were provided to the Navy to support Navy small-sat efforts. The SMDC-1 successfully demonstrated over-the-horizon communication to Army radios from a 3U CubeSat. It's pretty significant being able to take a small package and demonstrate something that could have potential use. And the results from this fed into the follow-on R&D SNAP program. SNAP was the Space and Missile Defense Command, SMDC, nanosatellite program. It was approved in August 2011 as a Joint Technology Demonstration, JCTD, program with mission to provide beyond line of sight communication from a 3U CubeSat. So taking the lessons learned from SMDC-1 and expanding the role of CubeSats from tech demos into platforms with operationally relevant capabilities. A total of 4 SNAP satellites were launched. One individual one was launched in December 2013, and then a set of 3 were launched in October 2015. Overall, the SNAP satellites successfully demonstrated the major mission objectives, building on the results from SMDC-1 with a more advanced and capable technology for beyond line of sight from 3U CubeSat, so demonstrating that operationally relevant capabilities could be provided from small satellites, and in particular for SMDC-1 and SNAP in the area of communication. Next was Kestrel I, the microsatellite program, so stepping up in size from a CubeSat to a microsat, with its focus being providing tactically relevant images to the warfighter. Its telescope and camera were capable of providing around 1.5 meter GSD images. It was launched to the International Space Station through the DoD Space Test Program in August 2017, and then deployed from ISS, as shown in the picture, in October 2017. After deployment, the satellite went through a series of checkouts, which culminated with opening the aperture door in April 2018, and then start of imaging. So the Kestrel I successfully demonstrated a rapid response to the ground warfighter in the area of images. So at this point, SMDC completed several programs focusing on both comms and on imaging. In addition to the 3 completed projects presented, SMDC has a couple of on-orbit active projects at the moment, one being the Army Cost-Efficient Spaceflight Research Experiments and Demonstration, also known as ACES-RED for short. And its purpose is to focus more on S&T projects, testing phenomena, technologies, and concepts, as opposed to focusing more on the operationally relevant to start, but identifying what could be useful, what could be used in space. So for example, the ACES-RED #1 satellite's a 3U CubeSat-sized payload on the ISS, and its purpose is to test ADAX components. In addition, there's a second ACES-RED satellite that's currently being developed, and is going to test advanced communication concepts. In addition to ACES-RED, there's also Harbinger, which is a CRADO with York Space Systems, and its purpose is to demonstrate small satellite near real-time image tasking and collection using synthetic aperture radar. So both of these efforts are focused on researching new technologies to develop future capabilities for the Army. In addition to the OnOrbit ones, SMDC does have several current projects in development, some samples here, such as Gunsmoke and Lone Star CubeSats that are going to be providing targeting data or space-based situational awareness to the warfighter, TACGEO, which is going to be providing electro-optical infrared, satellite supporting the tactical land component forces, and then Polaris, providing space-based capabilities in addition to the warfighter. So all of these, the takeaway is SMDC is continuing, not just on these done in the past, but is continuing to demonstrate advanced capabilities from small satellites for tactical support to the ground warfighter. So in addition just to the efforts, there's also laboratories that SMDC has within the Technical Center, one being the Concepts Analysis Lab, which is primarily staffed by engineers and scientists very early in their career, typically right out of college. And it performs research and engineering projects in support of all of SMDC's mission areas. So not just space, but it does support space. And for example, the picture shown is a set of CAL personnel standing next to an antenna that was built in-house and used for the Kestrel I program. In addition, there's also the Quantum Entanglement and Space Technology Lab, which was established in 2018 to research and demonstrate quantum science applications for the Army. And one of its focuses currently is planning and developing payloads for the upcoming ACES Red No. 2 mission. So SMDC is very dedicated to growing internal capabilities for the future. Additional laboratories that SMDC has is the Position, Navigation, and Timing, the PNT Resiliency Lab, which was established in 2017 to assess and develop new technologies, techniques, and prototypes to assist with providing assured PNT. In addition, there's also the Payload Demonstration Lab, the PDL, a picture of which is shown on the slide. It was also established in 2017 to centralize command, control, and telemetry ground infrastructure into a shared architecture for SMDC Tech Center small satellite projects. So instead of having to develop a separate ground station architecture for each satellite program, the concept was to develop one lab that could provide a common ground system architecture to use across SMDC's programs. And lastly, there's also the Reliable Expandable Satellite Testbed, REST, which is hardware in the loop and software in the loop testbed, ranging from components to constellations. So these laboratories provide resources to enable inexpensive demonstrations of technologies, components, or simulations of satellites to get them from ideas to realities to support the tactical warfighter. So in conclusion, SMDC is the Army Force Modernization Proponent for space, high altitude, and ground-based mid-course defense. Over the past decade, SMDC has conducted S&T research into small satellite technologies to support the ground warfighter, starting with SMDC-1 launch in December 2010 and building up to Kestrel I and beyond. And all of these demonstrate that small satellites have the capability to provide tactically relevant value to the Army. In addition, through these missions, the Army developed the Army Tactical Space Strategy nested within and supportive of the National Defense Strategy. So these lessons are very beneficial to the Army developing strategy in the future. Thank you very much.